So now let me explain how to get the Z pi 1 handle chain complex. So you proceed as follows. You choose a base point, x0 in M, say. The base point can be anywhere. We're assuming this is connected. And then for each I handle, each handle gets a threading. Now, what I mean by that is we choose a path from our base point to the center of the handle. So I'm going to call this gamma alpha for the I handle alpha, from the base point to 0 cross 0 in our I handle. So that was di cross d m plus 1 minus I, or is it in this case m minus I? I think it's m minus I. And that's called a threaded handle. Then when we have I plus 1 handle attached to an I handle, we can give it an incidence number in Z pi 1. And we do that as follows. So for hi plus 1 beta attached to hi alpha, we define the incidence number of to be. Now we sum over all points in the intersection of the attaching sphere of the I plus 1 handle and the belt sphere of the I handle. And we sum with the signs we defined over here. But importantly, we're using these threadings to give us an element of pi 1. So what this means is we first go out along the path gamma alpha. That takes us to the center of the I handle alpha. Then we go via the intersection point. So we choose any path to the intersection point. Then we choose a path from the intersection point to the center of handle beta. And then we go back along gamma beta in the other direction. And that takes us back to the base point. This gives us an element of pi 1. So in a moment we'll have an example so we can see what's going on with the torus. So I've just explained in words what this means. So this is then in Z pi 1 of well, I guess W. Yeah. And this is, it doesn't matter, it should be easy to see that it doesn't matter what path we choose, they're up to homotopy, they're the same. We get, this is a well-defined element in Z pi 1. And then what we do is we define our chain complex. We just say that the kth pi in the chain is just we get a Z pi 1 copy of Z pi 1 for each k handle. We get the free Z pi 1 module given by, generated by the k handles. And then we define the boundary map using the incidence numbers. So dk from ck, which is that thing, to ck minus 1, is defined by, if we have, say, k handle alpha, the boundary map gives us the sum over all handles it's attached to of the incidence number with that handle and then the generator of that handle. And this should square to 0 because the handle chain complex is essentially a fattened version of the cellular chain complex, which we can assume has a boundary map that squares to 0. And in fact, this is naturally isomorphic to, so the homology of this naturally isomorphic to the homology of W rel M with Z pi 1 coefficients. So we'll finish with one example, just seeing how this works. So the example will be the torus S1 cross S1 considered as a cobordism between the empty set and the empty set with the following handle structure. So do a nice big picture so it's clear what's going on. And the handle structure we get is, so let's start on this side. First we attach a 0 handle, which is a D0 cross D2. This gives us a disk around like this. I'm going to call this H0. This is our 0 handle. And we'll take this point to be our base point X0. Then to this we attach a 1 handle, which is a D1 cross D1. And this is going to go through here, through the hole, whoops, and attach on the other side. And this will have, this is attached, the attaching sphere are these 2 points. Then we also have another 1 handle attached, so first round the back, and then round the front, like this. So it goes all the way over that end, and this is attached at these 2 points. Incidentally, the belt spheres of the two are S0 here and here, and there's an S0 not very visible, say here and here. It's the belt sphere. And then finally we attach, I should have said this is going to be called H1 alpha, and this one is going to be H1 beta. And finally we attach a 2 handle, which is the rest of the torus. I'm just calling that H2, and that's attached along all these lines on the 1 handles. Now we need to thread all our handles. So first of all, Gamma naught is just going to be trivial. It's just the path from this point to itself without moving. Then gamma alpha, well, here's the center of the one handle. Gamma alpha will choose to go this way. Along that part of the handle. Gamma beta will take down here to the core there. And then finally we need to, the center of the 2 cell is roughly here, and we'll just take gamma 2 to go there in this direction. So we've now threaded all our handles. Then we need to orient everything and calculate signs for the intersections of attaching spheres with belt spheres. Now, I'm just going to write down the correct signs. You should take my word for it, but it's correct because it works. So I got a +1 here, -1 here, +1 here, -1 here, +1 here, and -1 there, and then -1 and +1